Me, my name is Abhishek Chabra. I'm very passionate about the compliance industry, have been around for about 15, 17 years, 18 now, across many sectors in the UAE. And since I have been with Thomas Bell-Wright, I have participated and get myself involved in many activities. For those who know Thomas Bell-Wright International Consultants, and for those who don't know us, we are a company that started about a quarter of a century ago, 25 years ago, mainly as a curtain wall testing laboratory and consulting body. And over the years, we invested in offering fire testing, started off with a furnace which is a 3x3 furnace for fire resistance testing and reaction to fire testing as per the American standard. Over the last 6 years, we have added many other capabilities, mainly in the building envelope space, where we have added reaction to fire tests for materials, large-scale fire propagation tests for cladding, as per the American and British standards. We've also augmented the availability of fire resistance furnaces. So we now have a total of 4 furnaces, a cube furnace, a 3x3, and 2 large vertical and horizontal furnaces, which are load bearing capability, which are 4 meters by 5 meters. Today, my session will focus on a better understanding of passive fire protection and compliance in passive fire protection. As we have a very broad spectrum of listeners, I would aim to talk code neutral and standard neutral and do a very basic introduction about what is pacifier for those who may be new to the concept. I will start this, as you can see, I will start a poll. So I'm going to open a poll and I'm going to run a short video for everybody. I know a lot of you come from a background where you would have seen fires, tackled fires. I know there are some people from the fire service who are in the audience. I would want all of you to generally imagine a room which I'm showing as a video that has a kitchen where a fire starts. And though a lot of you may understand this very well, I want that we all understand and just close our eyes for a minute and imagine that there is a fire. Either imagine it to be in this room that being shown as a video, or you can imagine a fire in any familiar location that you have, maybe your offices or your homes, and just try and visualize where the fire will go, why the fire will go in a given direction, to just get an understanding of how fire propagates, how fire will move around. I would encourage all the listeners to answer the questions in the poll. I still have a minute, and this is a request also from a point of view that people who would require the PDH to be given in the form of a certificate would need to have answered the polling questions, because there will be an evidence capturing of the names. So for all of you who have imagined or have been able to imagine this, would understand that when fire does move around and propagate, several things happen, obviously, as we have seen. I will pause for a few seconds to help people answer the polling questions and enjoy this video that I designed with the help of experimenting with my computer skills and using SketchUp. I'm hoping all of you have been able to imagine a fire scenario, and you would understand that there are 3 parts which are very important when the fire was happening. It is very critical that fire is contained and does not spread. Second aspect, which you would have imagined if you were trying to see that there is a fire happening in a room around you or in a location where you would not want the fire to move forward, is that you need to prevent the ignition and spread of fire. And another aspect which is not coming up in the example is what is called structural fire protection, which means that if you imagine a large building, something like the Trade Center, which was a good example where people learned that a fire could lead to the structure of the building coming down. I would like to share the poll results with everyone. I hope you can see the poll results in the screen of how many people think what all is responsible or can be responsible. Moving forward, I would like to talk with everybody, saying, well, these are the three areas where fire needs to be contained. How fire protection typically works is, as a lot of you may know, active and passive fire protection as terms are very well known. All equipment and systems which are designed into buildings that activate when they sense or see a fire are known as active fire protection measures or systems, like annunciators, smoke detectors, alarms, and anything that activates when there is a fire comes under the category of active fire protection system. And all the materials and systems that passively, as a property of the material itself, ensure that the fire does not spread, does not initiate, or is remained to be contained, is known as passive fire protection. This is broadly divided into resistance and reaction to fire. The resistance as a property is a property to define containment of fire using elements like fire rated partitions and doors, or even compounds and materials used to extend the structural integrity of materials, so that how long can materials resist fire. Reaction to fire is a very broad term because a carpet could ignite but need not necessarily spread the fire. It may not have enough for the fire to increase many fold. In the same way, there are several such properties that define reaction to fire, and I will be detailing about them in the subsequent slides. With this kind of a background, and I think a lot of you would have imagined how fires can spread, it is good to get an understanding of how people want to design and limit fires from getting spread. A lot of you may understand that the fire risk varies from many different buildings or building types. Often a terminology of occupancy is used in codes to define what is the type of building or type of occupancy that can be very risky, whereas others that could be less risky. I will open a quick poll question for everyone to give me your perspective of how fire risk can be there. I have given an option of a residential low rise, commercial high rise, or retail or large assembly and industrial type of buildings. This is related to how different countries and different types of contracts would write in either specifications or create technical laws around the concept of implementation of fire protection. A lot of you will agree with me that certain types of buildings are more risky. A small set of row houses would be less at a catastrophic risk of a fire as compared to a complex high rise building or a complex structure like a mall or an airport, wherein all the people using the infrastructure may not necessarily be familiar with what are the ins and outs of the buildings or the infrastructure. Hence, as a very general outlay, the type of building and the complexity of a building defines the risk, and the level of awareness of occupants of what to do in a potential fire scenario defines this risk. I will not go into details of this, but I will discuss these things mainly from a perspective of passive fire protection as one of the means which is used to implement protection of the infrastructure against a fire incident. Let me quickly share with you the result of the poll for the audience to see how everyone else around has replied or responded. It would be good to get a quick chat reply from people that you can see the poll results on your screens. So the three constructs of passive fire protection, namely containment, ignition or spread, or structural fire protection, needs to be understood that how it looks and what it reality may be. Many of us would imagine containment to be something like that you see in an image. A wall, maybe see through, or a door as a system that could contain or limit the fire initiated in a location to move from one place to another. But in reality, these fires that need to be contained are contained using building materials at a very basic form whose properties need to be evaluated. And there needs to be a tool for assurance that how a set of boards manufactured in a manufacturing location or wood panels, which could potentially be converted into fire rated doors, along with various hardware and other elements, which you can see, or maybe as you can see in the screen here, fire stopping system which is not visible to everybody. This is above the false ceiling where you have cable trays, HVAC ducts crossing over the partitions of two rooms which may or may not be visible. How these need to be put in place to ensure that fires are contained as originally desired. In the same way, ignition or spread of flame has a behavior of several interior finishing materials, upholstery, fit out, curtains, carpets, etc., needs to be evaluated and understood as part of ensuring that there is fire protection in place. As mentioned briefly, and I am not detailing structural fire protection and fire resistance from a perspective of structural integrity, but a classic example comes off from the video that chemical compounds and other measures and materials used to increase the structural fire protection or the ability of structures to sustain prolonged fire so that they don't lose their structural integrity needs to be very carefully understood and imagined, that how an assurance mechanism needs to be in place, that they are implemented properly as against how they are assumed to be implemented. Moving forward to talk about how passive fire protection as a concept, as a means to reduce fire risk, is implemented in different parts of the world, in different projects, different jurisdictions, and different types of occupancies or types of buildings. I must take a step back to talk to all of you and share the fact that the way the construction industry would have evolved to build and understand and implement laws in London versus the similar set of stakeholders of contractors and architects and consultants and material suppliers sitting in Mumbai in India or Texas or New York would all be different, not only because the climatic conditions and the environment are different, but also because of the fact that the availability and supply of specific materials in those regions could be different. It should understand that all these regions, municipalities, people have learned that from past incidences, either in the region or locally, some internationally, how they have led to the region's learning, individual learning of how a fire can happen, how a fire will develop, as well as comprehension level of residents and users of that area. Codes, contracts, legal constructs used to prescribe minimum requirements that should be put in place to ensure the life, safety, and property safety against fire. Hence, always come to be coming from different perspective when we try to compare codes and their implementation. So if you are looking to design or understand fire protection, it is good to go back and imagine, like the video at the beginning of the slide, that what actually can happen in a fire. And then comprehend that in intent, the codes, the technical regulations and requirements that are put in place or that are published to guide everyone else on how fire protection can be designed into buildings, how these things originate, how these things change over a period of time. As an example, you would know that in many countries, passive fire protection and active fire protection compete with each other. There are areas where passive fire protection is given less importance because active fire protection is given more importance, and so on and so forth. It is good to know and understand that sprinklers, as an example, may be very, very reliable and effective in certain parts of the world, but may not be reliable in other parts of the world. And hence, the intent of the code, their ideology should be understood when people are writing contracts and coming up with techniques to implement the measures for fire protection. Because we will be talking about passive fire protection only, I want to quickly go through a slide and talk to all of you about how you feel or how you understand the terminologies which are often used by different people. Fire rated and fire retardant as two terminologies are often misunderstood by certain people in the industry. I'm going to open a quick poll to get view from all of you and how you understand what are the properties which are usually understood as passive fire protection. But for those who are looking at the screen, I want to dig and drill a little deeper into explaining reaction to fire properties, which are often clubbed up to say fire retardant material. It is important to understand that ignition temperature or ignition as a behavior or property of a given material, along with the property of, let us say, heat release rate, which is written in red here, which can also convert to something called calorific value, which means that how much material is available in it that will burn, almost like the calories of sweets that we eat and we need to watch. So imagine a situation where you have a carpet which has a very low ignition temperature and a very low heat release rate or calorific value, almost like paper, which can catch fire very quickly, but may not create enough energy or enough heat to cause a lot of ignition. But if this material is lying next to a table, which has a very high ignition temperature, but also has a very high heat release or calorific value, which means the amount of energy inbuilt in that material is high, then it is good to imagine and understand that bringing such materials together could lead to a catastrophic situation where an initiation of fire caused by one could cause the fire to grow heavily in and onward. So I just want everyone to be kind of on the same page to understand that fire rated as a terminology, which is a terminology to define the capability of containment or resistance against a prolonged fire, often defined in number of hours or minutes, and sometimes also other terminologies of insulation, etc., are used. And I'm not going in deep at this point of time to these properties. I am just going to quickly show everyone how a good percentage of us replied to the poll questions. And I'm going to show you a brief video for you to see how fire tests are done. I'm sure a lot of you may have seen many fire tests, but it is important to understand that when a fire door is being tested in a laboratory, it is a given set of materials and systems that are brought together in a defined design and installed, and they are tested. In the same way as reaction to fire of materials which are tested, you will see a small video running here, which is the video from a room corner test, also known as single burning item test. A lot of you may already be familiar with the test. But one of the prime reasons to show this video is for all of you to try and imagine that when a test like this is being conducted in a laboratory, it may not capture all the tests that have been done prior to a given test whose result gets published and is viewed. It may not always capture of how these materials were put in place, were designed, were brought together, were installed, yes, but not necessarily how they were manufactured. Keeping this in the background, I want to shed a very tiny bit of light on testing methods. Though I promise that the webinar will be standard and code neutral, I just want to bring about the fact that there is a fair degree of spread in terms of test methods that are available to choose for authorities having jurisdictions, for codes, for contractors, for designers, and it is always good to keep a good idea and good knowledge of what are the standards which remain more up to date, which are more often revised to take feedback, and hence test methods which are more current, are always better to be used. Here is a list of some of the fire resistance tests that we offer in our laboratory, but the list should not be considered as exhaustive because there are a large number of other tests. I want to bring about a fact that the European tests that exist for some of the fire resistance properties, as you can see here, are separate test methods for separate types of products. For example, walls and partitions, for load bearing or ceilings or floors and roofs and boom. There are separate test methods which have been published for these. Whereas if you look at the test methods which are American, for example, the ASTM E119 as a test method, you would notice that these are one single test method written for several types of partitioning elements. So in the same way, I will share a quick list of the test standards. I know that a lot of you will be using the recorded webinar and would want to see these standards. I am seeing from a lot of people that they are keen and eager to get a copy of this presentation. And I think a best way to get a copy of this presentation is just to download the video link, which I will share. And you can, of course, see all the slides and hear me speak as well. Moving forward to just explain how these test reports are often used. I showed a quick video of some of the tests. It is important to know and understand when we are taking decisions of selecting certain materials, certain types of materials based on the test reports that are available or visible or are shared. It is important to ask this question when a test data, test report, or test evidence is presented, that how this test data will link with the supply of the material that it will be done in the future. Of course, the use of test reports is only for getting some evidence and some level of assurance that in the future, if I utilize a given material to bring about fire protection, passive fire protection, then it will function in the way it is being asked or it is being talked about. And this is where a lot of people may already know this. The concept of certification and listing links test reports with what will get supplied to the construction site. I am going to open a quick poll in the next slide just to get an idea for how many people in the audience may already be understanding the concept of certification and listing. You will see the poll opening on your screen. The certification and listing as a concept has an independent third-party body who will create a link between the sample that gets tested at the manufacturing location which is defined, and also by means of an audit scenario, they will ensure that the manufacturing location which is listed on the certificate, which is available for anyone to verify online by going to the certification directory, is supplying a given material which will comply to given properties. And often the certification body would provide a traceability number or a certification number which needs to be displayed on the material supplied to the construction site. I am sure a lot of you may already be aware of this, but if you look at the back of the laptop charger or a power adapter, you would see lots of numbers and certification marks. If you search for any one of them, you would very, very quickly see that who is the third party certification body who is actually auditing the manufacturing location of the supplier of a given power supply. And hence, a traceability of material is available and is visible. This is the level of traceability that needs to be established for materials which are providing us a deep sense of comfort and assurance that if we have designed fire protection using passive fire protection as a concept, these materials will perform in the way they have promised to perform. And this is very, very important because we need this level of assurance for materials where we are relying for the life and death of people or ensuring that the properties of or the infrastructure will live as long as it should. I will take a quick example of fire doors and how fire doors in a given project demonstrate this compliance. For people who are aware of this, would know that in a given project where the fire and life safety plan designed either on the basis of inputs from the minimum code requirements set in by the legal authority around, or the designer slash consultant or architect who may have increased the compliance requirements or fire safety requirements of a given building. As an example, it is common that large international hotel chains or airports would follow minimum compliance requirements higher than those set in by the local authority having jurisdiction. So once a fire and life safety plan devises a methodology which calls for fire resistance rating to be implemented across a building, it creates what we know as a door schedule, which means you can imagine a spreadsheet which has a list of maybe sometime hundreds of doors which are defined and pointed which door will go in which location in a given building. And what is the fire resistance rating that was mandated for it? Now, this forms almost like a RFQ document for a door supplier to say, well, I will provide and sell 500 fire rated doors for a given project, as an example. And it is very common that these 500 doors are different. Maybe only 300 or 200 or 100 are exactly same. So how do you assure that the doors which will arrive on the construction site on your project will comply? And this is where assurance mechanism becomes important. You could have a contractor who simply relies on a supplier just on the basis of past experience and faith, almost like how banks would give loans about 30 or 40 years ago when people had faith. But the third party assurance provides a very objective mechanism where certified listed door designs provide proof that certain changes in the designs which are required for a given project may or may not function. So the tool of assessment provides an additional level of assurance to buyers of fire doors, and often certification bodies, compliance bodies go to an extent of issuing fire door labels which often capture enough information for the inspector at the construction site who is overseeing the installation to check that what is the link between the doors that were tested or assessed to perform in a certain way and the doors which have reached the construction site. At this stage, I am not delving deep, but there are published standards like NFPA 80 for fire door inspections or installations, which define very specific methods to bring about the assurance which is badly needed to bring about. So I am summarizing this in a quick block diagram wherein manufacturer would typically conduct several fire tests to arrive at not necessarily one, but several certification and listings combining different designs and different materials. This set of tested, listed door sets are then used as a basis to convince a contractor who would want to procure doors as per a defined door schedule. And often, door manufacturers use additional evidence like assessment documents to provide the additional assurance needed for the contractors. And contractors then procure the doors as per the door schedule, and depending on certain jurisdictions that may even mandate labels, or you could go into a contractual requirement where labels are needed as a tool to provide the assurance badly needed, and inspections are done on the basis of not only the labels, but a lot of additional information provided by the door supplier on how the door set should be assembled, should be installed, etc. Because these are as critical as everything else. A fire door tested and certified to behave in a certain way, if installed incorrectly, skewed, for example, is no longer a fire door. Moving forward to a slightly trickier part of passive fire protection is the interiors of given buildings. We know that more often than not, there are several components of the interior of buildings, infrastructure, whether it is hotels, hospitals, malls, commercial buildings, residential buildings, where the interior fit out is bespoke, is designed for only a specific building. The classic example is carpets, but it goes on for several other material and product types. So how do you check for compliance? I will summarize this method in a block diagram as well, but it starts with the stakeholders. There are stakeholders, which I am currently talking of as architect slash consultant, but they are the ones who would either comply to the requirements or the minimum requirements set in by the government, or add to these requirements additional requirements which are related to the risk or the assessment of risk of a given infrastructure or a building, and define the compliance requirement using test methods. The contractor who needs to take ownership of the compliance because he is procuring and he is building and providing a level of assurance that what he is procuring will perform in a given way, would often take samples from the supply at the construction site, often overseen by the consultant, to create a traceability by marking the samples. And these samples are then tested in an accredited or a recognized laboratory. Often the tests are witnessed to ensure that they are installed in the same way they will be installed in the construction project. And such test reports, along with the inspection report of how it was actually installed on the construction site, add to the much needed data or dossier, which is either submitted to the authority having jurisdiction or forms the basis of the contract against which the payment will be made, or just remains as a dossier that may be referenced in the future in a rare case of a fire incident to understand who may have erred in the process causing a fire. Here is a rather complicated block diagram to explain the whole thing, where manufacturers, contractors, and consultants who write the fire strategy of a building are set as stakeholders, wherein typically, but not necessarily always, the consultant or the fire consultant would publish the specifications of performance and may even oversee the implementation of this. And as described earlier, that the contractor and manufacturer, together with the consultant, will ensure that the process of choosing the samples from the site, maintaining its traceability, and going back to get the test report clubbed with inspection of how the material is installed on the site form the basis of assurance. So moving to my last slide and summarizing how assurance is done for properly implementing passive fire protection in projects. For standard products like fire doors, for designed systems like cladding, which I covered in my previous webinar. And if anyone is interested, I can share a link of that webinar. And for bespoke systems and supplies. This is the last slide. I would take a break for a few minutes, and I will just go through some of the questions which have been coming to me, in some in private as well, and I would be addressing a few questions, maybe 3 or 4. So please feel free to type in questions while I take a minute's break to read through all that people have been sending me over the chat. So let me start taking some of the questions. I will take one question which is very commonly asked. The question talks about the door hardware being changed on an approved fire door assembly, and whether this would call for a full or a pilot scale test to be assessed. And the answer to this and similar questions related to several changes that are or potentially do happen is common. Fire door assemblies are slightly complex systems, and there are several parameters and several constructs that come in play, wherein ensuring that the supply of all the hardware and components of the door remains the same. And hence, if a certain piece of hardware has been certified and listed, which means that just like the manufacturing location of the fire door supplier is being audited to ensure that the quality is being maintained, it is relatively easy to swap and change the listing as against using a second hardware which may not have been listed or may not be under an audit regime of a certification body. I am getting more than one question related to Indian standards, and I am aware that the newly finalized Indian standard for fire doors is not yet published, but as a laboratory servicing and supporting the Indian market, we already have added accreditation to the fire resistance standards, which are referenced in the National Building Code of India. And we aim to take on the accreditation as per the IS 3614 once the standard is published. And we are aiming to offer 2 test reports in one fire resistance test, if possible, wherein we conduct the test as per the British standard or the European standard and issue 2 test reports, which will help not only manufacturers from India gain offering of compliance to the international market, but also vice versa, where people from outside India can conduct 1 test to address the Indian market as well as the other markets. I will take one last question, and I think I will have to address the rest of the questions in emails because the screen is just scrolling very, very quickly. There is a question I would like to address where a lot of people shirk from using third-party certification because it adds to the expenditure of the whole process, wherein procurement of certified products, let's say from a given certification body or any certification body, would be more expensive as against non-certified products. And the answer is not a straight answer because, as one of my slides mentioned, that risk and the potential of a fire incident happening is reduced and minimized by designing in fire safety using active fire protection constructs, passive fire protection concepts, and reducing of this risk, reducing of potential liability is based on this assumption that whatever is designed will perform and will function very, very well. Now, it is up to you as a buyer or an insurer or an authority having jurisdiction to set in the minimum method by which you will rely on something. As an example, if you are buying potatoes to cook food in your house, the depth to which you would want to do quality assurance would be very different as compared to a table fan, which has a slightly higher risk inside the house. I hope that kind of tries to answer that question. I will take one last question, which I get asked a lot, and the balance questions I will reply in an email. This is a very common question coming to us when we are asked to compare standards. Being in the Middle East, not only as a laboratory, we offer to test as per several standards, American, British, European, and hopefully soon Indian as well, as against those geographies where the national standards prevail. It is common that in the construction and in the projects, the supply of hardware is having proof of compliance to a British or a European or an American test method, whereas the system, like a door set, is complying to a different test method. And I would like to compare or try and compare the fact that an American test method is different, excuse me, in more ways than one as compared to a British standard. And they are not the same. Some experts could write engineering judgments and assessment based on limited knowledge that they may have or experience that they may have. Depending on the risk of the procurement that you're doing, I would recommend that you get a test report to get the level of assurance. I would like to thank everybody for joining me for this webinar today. The last slide, as you can see, has my contact details and my number. You also have the email address for everyone who may want to get a professional development hour or PDH certificate. Please note this down. This email address is where you will have to send an email to get a copy of your certificate. And I would now be thanking everybody for taking out your time to listen to this webinar. I hope the webinar added to your understanding of the subject. There are lots of questions, as I mentioned, and I will reply to each one of you in an email, or if required, I will probably plan for a phone call with you. Thank you very, very much.
Thank you.